So this is Dr. Eads, and this is the first video for Physics 2, Physics 273, and this is going to talk about electric charge, which covers some of the stuff in chapter 23.2, 23.3, and 23.4. Okay, so first off, basically, well, a big part of what we're going to be studying this semester is electricity and electric charge. So what exactly is electric charge? Well, electric charge, one way to think about it, it's a fundamental property of certain elementary particles, and it determines the strength and the direction of electromagnetic interactions. So certain particles, things like electrons and protons, for example, have this property called electric charge. And if you have two charged objects, they experience an interaction or a force. So usually, to symbolize electric charge, we're going to use a Q, either a lowercase q or a capital Q. The SI unit of the charge is something called the coulomb, which is abbreviated with a capital C. Now, 1 coulomb, as it turns out, is actually a huge amount of charge. So we also talk about something called the elementary unit of charge, and the elementary unit of charge is the amount of charge on an electron or a proton. So, and this is abbreviated with a small e. So if you have an electron, it has a charge of 1.602 times 10 to the minus 19 coulombs negative. And if you have a proton, it has a charge 1.602 times 10 to the minus 19 coulombs positive. So the E, the symbol E here, it usually just means the absolute value. So an electron has a charge of negative E, the negative elementary unit, and a proton has a charge of positive E. Okay, so some properties of electric charge. Well, of course, there's two different kinds of electric charge. So this was, well, this has been known for a long time, so Ben Franklin gets the credit for denoting them as positive and negative. So, and of course, if you have two charged objects, there's going to be a force between them. So, and like charges repel and opposite charges attract. So if you have two positives or two negatives, you get a repulsive force. If you have a positive and a negative or a negative and a positive, you get an attractive force. So electric charge is both conserved and quantized. So remember, in physics, conserved means it's not created or destroyed. And quantized just means it comes in chunks. So you can't have any charge you want. So you could think of it, it comes in units of this elementary charge, units of this electron charge. So electric charge is found in these discrete little packets like protons and electrons, and you can't create or destroy it. So another important thing is that we often talk about neutral objects. And neutral, well, that means it doesn't have a net charge, but that doesn't mean that it doesn't have any charge, right? In general, everything's going to be made of atoms. Atoms have lots of protons and electrons, so it has lots of charge. So a neutral object just has equal amounts of both positive and negative charge. Okay, so some other properties. So to charge, so if you have, say, a neutral object, well, to give it a charge, an important thing to remember is that you aren't creating new charge. You're just moving around the charge that's already there. And today, of course, we know that it's actually the negatively charged electrons that are typically the ones that move around. So there's two main methods of actually charging an object. One is referred to as charging by contact. The other is charging by induction. We'll see some examples of those in class. And some other important terminology. So if you have a material, so broadly you can divide materials into two big classes. So conductors, so things like metals. So in a conductor, the charges, and now we know the electrons, are relatively free to move around, right? So this is why you use metals like copper and things for electric circuits, because the electrons are relatively free to move around in the conductor. On the other hand, you can also have an insulator. So in an insulator, charges are not free to move around. So there's also things called semiconductors, and I think we'll actually get to talk about semiconductors, which is kind of in between a conductor and an insulator, towards the end of the semester.